Welcome everyone to Algebra 1, Section 1.2. Today we're going to be talking about order of operations, absolute value, and evaluating expressions. So absolute value, we often think of it just as making everything positive. Now the actual definition is going to be the distance from 0 on a number line. So if we think of a number line here, and I'll just do it in some space I have right here, a number line, and I start numbering off things. And I have 0 in the middle. Okay? And let's say we're talking about the absolute value of -3. And the absolute value of -3, we'd say, okay, well, how far is -3 from 0 on a number line? So I put -1, -2, and -3. And so if I count, I say, there's 1, 2, 3. So absolute value of -3, well, -3 is 3 away from 0 on a number line. And as well, positive 3, 1, 2, 3, if I were to say what's the absolute value of positive 3, that is also 3 away from 0. I went to the wrong spot. I started at 4 there instead of 3. It is also 1, 2, 3 from 0. So the absolute value of positive 3 is also 3. And even though our working definition that we often use of it makes everything positive is helpful and it'll work for today's lesson, future lessons will necessitate or require us to use this definition for absolute value as the distance from 0 on a number line, which is why I'm emphasizing it now. So later in a future unit, we can reference back to this. So for now, let's go ahead and just evaluate some absolute value expressions. So number 1, the absolute value of -13. How far is -13 from 0? Well, -13 is 13 from 0. It's positive 13. Number 21, or number 2, absolute value of 21. How far is 21 from 0? Well, 21 is 21 away from 0. Or it's already positive, you can think about, so it doesn't need to change. Now, it is important to note, I went to say this a moment ago, that when we're talking about the distance from 0, that distance can never be negative. It's not that if you drive one way on a road, we call it positive distance, but if you drive the other way on the road, you call it negative distance. Or if you drive forwards, it's positive, but if you drive backwards, it's negative. Regardless, whether you're driving forwards, backwards, or north or south, or whatever directions, you're always driving positive distance. So distance is always positive, which is why absolute value makes everything positive. So number 3 here, the absolute value of -3 is positive 3. The absolute value of -5 is positive 5. So this is really positive 3 plus positive 5, or 8. I would encourage you to go ahead and pause the video, try as many of these as you can on your own, and then resume the video to compare answers or get further guidance as needed. Number 4, positive 9 and positive 8, because the absolute value of everything makes everything positive. So 9 plus 8 is 17. Number 5, we get positive 12 plus 15, and that's 27. Now on number 6 here, we got to be careful. We might just think, oh, we automatically make that positive because it's absolute value, and we add those two. But that's not quite correct. We only make it positive once we're done doing all of the math inside the absolute value. So we actually do the subtraction first. We do whatever operations are inside first, and then we make the result positive. So we say the absolute value of 21 minus 17 is the absolute value of 4. And the absolute value of 4 is just 4. So number 7 now, we have the absolute value of -11, that's 11. The absolute value of -5, which is 5, and we're subtracting the two results. So we end up doing 11 minus 5, which is 6. So even though each individual absolute value produced a positive number, we still subtract it because that was assigned between the absolute value expressions. Same thing would be true here in 8. We'd end up having 4 minus 4, which gives us 0. Number 9, 15 minus 23 is -8. So we say the absolute value of -8, well, that would be positive 8. Because 15 and 23 are 8 apart. Number 10, we have 24 minus positive 15 after doing the absolute value, and we get 9 as the result. Number 11, we get 28 minus a positive 26, and we get 2. So notice I'm not changing the two signs in a row on them like on 7 or 8 or any of those, or 10, because we have to do the absolute value before we can deal with the subtraction. So we have to actually make this number positive, and then we subtract, making it so there's only one minus sign here in this case. Number 12 here, we have -3 and -19. So the absolute value of -3 minus the absolute value of 19, my apologies. So that'd be 3 minus 19, or -16. Now let's talk about order operations. The order operations is the order used to simplify expressions. Expressions just mean we don't have equal signs. Otherwise, it'd be called an equation. So the order of operation. So the first step is that you do any parentheses. Oh, my pencil glitched out a bit there. And other grouping symbols. So you do parentheses and other grouping symbols. So parentheses are a type of grouping symbol. Now some examples of grouping symbols would be parentheses, brackets, absolute value bars, and braces. So we do everything inside of those first. And so we're going to use the capital letter P for parentheses. Next, you would do any exponents or roots you see. So if you see square roots, which we'll get into more later, or exponents, we do those next. And so that would be the capital letter E for exponents. Next, we do any multiplication and division. There we go. From left to right. So a lot of people end up actually making a mistake on this step where they automatically do all multiplication first and then do all division afterwards. However, that's not how this step is actually applied. What we do is whatever we see first, we do first. So if we have 5 times 3 divided by 3, we do this multiplication before we do the division because the multiplication is on the left. However, if I change that up and instead we have 5 divided by 3 times 3, we would do the division first because the division appears first from left to right. And that'll be the letters M and D to abbreviate that step. And then our fourth and final step is doing any addition and subtraction. And like multiplication division, this would be done from left to right. And so we'll use A and S. So similarly, we don't just do addition first, we don't just do subtraction first. It just depends on whichever one appears on the left side or further left. So let's practice applying these. And once again, I'm going to encourage you to, with all of these problems, try as many as you can on your own before just watching me do them on the video. So you might need to pause multiple times here. Maybe, watch me do a problem, then you do a problem, and then watch how I do that, and then do another, and then watch how I do that, and so on and so forth. Whatever works for you. Number 13. So we have addition, we have division, and these are multiplying together. So order of operations says multiplication and division come before addition, and division is on the left here of the multiplication. So I do the division first. So if I'm not doing anything with that 7 plus, I'm just going to rewrite it. And now I do 54 divided by 3, which is 18. And then I have 18 still multiplied with 2. So next would come this multiplication, which would be 7 plus 36. And now adding those results in 43 as our answer. Number 14. The first thing I see is an exponent. So I do 2 to the 5th power. That means we have 5 of the base. We call whatever's being raised to a power of the base. So in this case here, 2 is the base and 5 is the exponent or the power. And so 5 2's multiplying together. Maybe I do that off to my side to make my life a little bit easier instead of making this problem super messy. So I do 2 times 2 times 2 times 2 times 2. And so I say 2 times 2 is 4. And I'll do 2 times 2 is 4 again. Bring down this other 2. And now I do, I don't know why I tried fixing that 4. I made it worse. So now I'll do 4 times 4 and get 16. And multiply that by 2 to get 32. So I have 2 to the power of 5 is 32. And I'll just rewrite the other things that I haven't used yet or haven't done yet. Now I'll go ahead and do division, because that would come before subtraction and addition. So I have 17 minus 8. 32 divided by 4 would be 8 plus 6. From left to right, I have subtraction first. So 17 minus 8 is 9. So 9 plus 6 is all that's left. And that results in 15. Number 15. We would first start with our exponent again. And so I'm going to have 24 minus 4 times 4, or 4 squared, is 16, times 3 plus 15. Again, this multiplication would come next. So I'll go ahead and do 16 times 3 and get 24 minus 48 plus 15. Next, I will do subtraction from left to right. So 24 minus 48 is negative 24 plus 15. And combining these two at negative 24 and a positive 15 give us negative 9. Number 16, we have a fraction here that's new to this lesson. And so what we're going to do is we're going to treat the numerator as its own parenthesis and the denominator as its own parenthesis. So we're going to do those separately. And once we finish the entire numerator and entire denominator, we'll simplify the two by dividing or reducing as needed. So inside this parenthesis is where we'd start. And inside the parenthesis we have both subtraction and exponents. So the exponent would come first, giving us 4. So we'd have 7 minus 4 still in a parenthesis, plus 14. Then on the bottom, we have addition and multiplication. So multiplication would come first, negative 14 times 10. I'm going to use this arrow here so you can follow my work. In the numerator, in the parenthesis, 7 minus 4 is 3, and I have 3 plus 17. I could put it in parentheses, but regardless, I'll be adding 3 and 17 whether I have the parentheses or not. Negative 14 times 10 on the bottom is negative, oh sorry, that should not be times there. I miswrote that because it's a plus sign. So negative 14 plus 10 is a much smaller number, and that's negative 4. Next, in the numerator, 3 plus 17 is 20, and I have 20 over negative 4. And now that I've done the entire numerator and the entire denominator, I simplify the two. Negative 4 goes into 20 exactly 5 times, and because it's a positive divided by a negative, we have one of each sign. Whenever we have one of each sign when we multiply or divide, our answer is negative. On this next page here, we have number 17. We start getting a lot more going on here. We have two grouping symbols, parentheses and absolute value. We can handle those two separately at the same time, similar to how we did the numerator and denominator of the fraction. So here, subtraction actually happened before this exponent because the exponent is outside the parentheses, while subtraction is inside of the parentheses. So 8 minus 5 is 3, and we have 3 to the third power, minus the absolute value of, inside the parentheses, exponents would come before subtraction. I said the parentheses, but inside the absolute value. 5 squared is 5 times 5, or 2 5s, and that's 25. 4 cubed is 3 4s, so that's 4 times 4 times 4. And 4 times 4 gives us 16. And 16 times 4 gives us 64. So we're going to have minus 64. Oop, I should stay in the same color to stay consistent here. Divided by 3. Now on the next step, 3 to the third power is 3 times 3 times 3. So 3 times 3 times 3 gives us 9 times 3, which is 27. So I get 27 here, minus the absolute value of whatever 25 minus 64 is, and that's negative 39, divided by 3. Next, I do the absolute value, and I say 27 minus a positive 39 divided by 3. So next would come the division before subtraction. So I have 27 minus 39 divided by 3 is 13. Now as I do 27 minus 13, I end up getting the answer to be 14. Number 18, we only have one grouping symbol, so we're going to work inside of that. Negative 7 squared plus 3 squared. So here I want to note something very specific. Because this is a negative 7 squared, this will actually be negative 49 for that part. The reason that is because we end up applying this as if it was written like this. We're saying we square the 7 and then make it negative. For instance, it's like negative 7 times 7, or 7 times 7 and then making it negative, which would give us a negative 49. Now, a difference there would be if it was written like the following. If it was written as negative 7, all in parentheses, square. So notice, in this one, the negative is in the parentheses this time. And so would that would be 2 of whatever is inside the parentheses. In this case, it'd be 2 negative 7s. So it'd be negative 7 times negative 7, which would produce a positive 49. So there's a little subtle difference there, depending on whether or not there's a negative sign inside a parenthesis or not, like you see in the problem itself. So with that being said, we're going to continue on. 3 squared is 9 times 4. Now, we have this plus sign, and we can actually go ahead and do this division. And here's why we can do the division, even though we're not done with this grouping symbol yet. The reason why we can do that is because the operations next to the division symbol, the operations next to division, are multiplication and addition. And division always comes before addition, unless the addition's in parentheses, which is not here. And division will come before multiplication when it's on the left, which is the case. So because this operation will happen before either of the ones around it, we can go ahead and do that operation in this step if we would so like. So I can do 18 divided by 2 and call it 9 at this moment. If you wanted to wait until a later step to do 18 divided by 2, that'd be perfectly fine. You just end up having more steps to your problem, which isn't a bad thing. It's just a different thing. It's really a matter of personal preference and what would be best for each of us. So now inside the absolute value, we continue on, and we would be multiplying 9 times 4 to get 36. And on the outside, we can do this multiplication. For the same reason as before, the operations around it, which are just the addition side this time, come after multiplication. So we can do 9 times 5 and get 45. Negative 49 plus 36 would be negative 13. And so the absolute value of negative 13 would add with 45. The absolute value of negative 13 is positive 13, and so adding that with 45 gives us our result of 58. Number 19, a fraction again, so we're going to deal with the top separately from the bottom. So from the top, we have some exponents that come first. 5 squared is 25. 3 to the 4th is 4 different 3's multiplying together. Writing it out can be incredibly helpful. 3 times 3 is 9. 3 times 3 is, again, 9. And 9 times 9 is 81. So 25 minus 81 on the top. On the bottom, we have 2 different parentheses, so we're going to solve each of them separately from each other. 2 cubed would be 8, so we have 8 minus 5 and 1, times, anytime you have 2 parentheses next to each other, they're multiplying. 6 squared, square would happen before the division, is 36, divided by that 9. Now I'm going to move it down here so I have some room. In the numerator, 25 minus 81 is going to be negative 56. In the denominator, 8 minus 5 in the first parentheses, 3. And the second parenthesis, 36 divided by 9 is 4. Now, whether I write this multiplication symbol or not is not important, because if 2 parentheses are next to each other, like I mentioned a moment ago, it means they're multiplying. So now I multiply the denominator, and 3 times 4 is 12. And now that I've done the entire numerator and the entire denominator separately, I will now look to simplify the 2. 12 does not go into 56 perfectly. However, there are numbers that go into both 12 and 56. We want to find the biggest such number. The biggest number that goes into both is 4. 4 goes into negative 56 14 times, and so it becomes a negative 14. And 4 goes into 12 3 times. So our answer is negative 14 over 3. Number 20. We have this grouping symbol, so we'll start there. The negative is outside, so the negative will stay outside. So you have the negative absolute value of negative 19. Two negatives add up to be a bigger negative. Plus, we can do this exponent even though it comes after the grouping symbols because it comes before division and addition, the signs around it, or the operations around it. 12 squared is 144, 12 times 12. We can't do this division yet because we are still using this 12 squared. We did that first. And we can't do the multiplication here because the division would come first since it's on the left. So I'll just continue to write divided by 6 times 3. I will go ahead and do the absolute value, which makes this a positive 19. However, this negative is still out in front. So we still have that negative. So this comes from there. Plus, we can do this division now. 144 divided by 6 is 24. And we'll have 24 times 3. 24 times 3 would come next. We have negative 19 plus 72. And negative 19 plus 72 is 53. Moving on to number 21. This brace is just another type of grouping symbol. So it's like a bracket or it's like a parenthesis. You can treat it the same way. So inside here, I'd look there, and I'd say I have two different sets. What do I do when I have two different sets of parentheses inside of the other? We do like the Pixar movie, and we work inside out. So I do the inner one first. So I do 5 minus 9 before doing anything else. And this exponent is outside the parentheses, so the subtraction would come before it. And that gives us 4. So we have 4 squared, 3 times the parenthesis, plus 2, that's all in our braces, which if you wanted to write parentheses is also fine by me, because they're the same thing in this context or in this setting. Divided by, I can go ahead and do this exponent because it comes before the only operation next to it, which is division. So 20 times 20, or 20 squared, would be 400. I do have to finish everything in there before I do division because grouping symbols come before division. So 400 divided by the next step, exponent would come before multiplication, and so we'd have the 3 times still there. And it'd be 3 times 16 plus 2. So multiplication would be next now as we do 3 times 16 and get 48. And we have 48 plus 2. And 48 plus 2 would be 50. So we have 400 divided by 50. Now that I've done everything inside of that grouping symbol, the brace, I can finally divide this too. Here's a life hack when you're dividing things that both have zeros. You can slash out or divide out an even number of zeros, or an equal number of zeros, I should say. So even though this one has 2 zeros, I can only divide out 1 because this one has 1 0. So you can divide out an equal number of zeros there. And now I really have 40 divided by 5. That makes my life a little bit easier to do and know that it's 8. 22, another fraction where the top has a grouping symbol inside of a grouping symbol. So once again, we'll do the top separately from the bottom and then simplify the 2 when we're done. And on the top, we'll start inside the innermost parentheses. And the innermost parenthesis has an addition and an exponent, so we'll do addition first. So 12 times the quantity just means things inside of the parentheses. So 12 times the quantity of 30 minus 9 plus 16 over absolute value of 10 is 10, absolute value of negative 6 is 6, and we're subtracting the 2 of them. Making room, I'm going to go over to the left again. In the numerator, that 12 is still hanging out there. That 30 is still hanging out there. The minus sign is still hanging out there. But 9 plus 16 is 25. On the bottom, 10 minus 6 is 4. On the top, 30 minus 25 inside the bracket is 5. Now we will multiply, and 12 times 5 is 60. And 60 divided by 4 is 15. Next up is 23. 23, my mind instantly goes to this parenthesis here, and I say the exponent comes before subtraction inside parentheses, or anywhere in that case, but because they're both in the parentheses. So we have 49 is 7 squared, and this minus sign is not inside a parenthesis, so we have minus sign still there between 5 and 49. Now, this plus sign will still be there, but I can go ahead and do this division, this fraction, because the only operation next to it comes later than division. So 84 divided by 12 is 7. Same thing here, I can do this division now, because the only operations next to it come after it, because the multiplication's on the right of it, and on the left it would come first, and then division comes before subtraction. So minus 72 divided by 6 is 12. So inside my parentheses, I will have 5 minus 49, which is negative 44, minus 12 times 2, which is 24. From left to right, 7 and a negative 44 add up, or subtract really, to give us negative 37. I say subtract really because anytime you have opposite signs, one's positive, one's negative, when you're adding, they subtract and you keep the sign of the bigger number. 44 is bigger than 7, and so we keep it negative. Even though negative 44 is bigger than positive 7, we say 44 is bigger than 7 for the purposes of knowing which sign to keep. And we still have to subtract 24. And when we do negative 37 and a negative 24, we make it a bigger negative. So they're the same sign, and so you add and keep the signs to get negative 61. 24 on the numerator. Going to see this parenthesis first and say 8 minus 11, we have negative 3, cubed still, minus 3 times the absolute value of negative 14 is positive 14. So you can either put a multiplication symbol there, or you can put parentheses around 14. On the bottom, 2 to the 4th. We did 2 to the 5th earlier, and it was 32. 2 to the 4th, however, will be a different number. So we have 2 times 2 times 2 times 2. 2 times 2 is 4, 2 times 2 is 4, and if I do 4 times 4, I get 16. So 2 to the power of 4 is 16 minus 7. Here I have negative 3 being squared, which means there's 3 negative 3's. So negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9. Multiplying that by another negative 3 gives us negative 27. So I get negative of negative 27. That's important to note that we have the negative from this and the negative out in front still. These are two separate negatives that we'll have to do something with in a moment. Here we have 3 times 14, or really kind of like a negative 3 times 14, and we have negative 42. Over on the bottom, 16 minus 7 is 9. Now those two negatives right here in a row are important to note, because since it's parentheses and not absolute values, we aren't going to be changing this sign just because of the absolute value. But when we have two negatives in a row, the negatives mean opposites. The opposite of a negative is secretly a positive, so we make them both positive. And so we have a positive 27 minus 42, and that's negative 15 over 9. Once again, that's because you have two negatives in a row with no operations between them. Next, negative 15 over 9. 9 doesn't go into 15, but 3 goes into both numbers and makes it negative 5 over 3. I do want to note that whether you put the negative out in front of the 5, in front of the 3, or in front in the middle, it's all the same thing. Regardless, we have one fraction that is negative. We regard it as one fraction that is negative. We don't regard 5 over 3 as two different numbers, but as one number, and that number is negative.